Hi Bobcats! In this video we're going to take a look at scientific notation. Specifically, we want to be able to take a number in normal notation and write it in scientific notation and vice versa. And I'd like for you to recognize that if you have a number in scientific notation and the power of 10 is negative, it means it's a tiny number, something smaller than 1. A positive power of 10 means that it's a big number, something bigger than 1. And we're going to take a look at multiplying and dividing numbers in scientific notation with and without a calculator. So scientific notation is a way of writing numbers that's really useful for very big and very small numbers. The two examples here show the two possibilities. Just to kind of go through the process, let's start with that first number. We've got 0.000135. To turn that into scientific notation, we need to move the decimal place over until there's exactly one digit to the left of the decimal place. So we're going to take that decimal as it's written right there, and we're going to move it 1, 2, 3, 4 times. If I rewrite that number, it'll be 1.35, and then we're going to multiply by a power of 10, because as we're moving the decimal, we're basically saying multiply by 10 or divide by 10 each time we move it. If we're multiplying by 10, that will give us a positive exponent on the power of 10 in scientific notation. If we divide, if we're dividing, that's going to give us, actually, did I just say that? I think I said that backwards. Anyway, what we're going to focus on is if that initial value of the number is smaller than 10, this needs to be a negative exponent. So we moved that 4 times. The initial value of the number is smaller than 1, so we're going to end up with a power of 10 that's 10 to the negative 4. With this other number, 18,900,000, if we're going to move that decimal, so there we go, 18,900,000. If we're going to end up with one digit to the left of the decimal, we're going to move it a bunch of times. Now, in this original number, the decimal point is not written, so it's understood to be at the very end of the number. So if I start moving that over, 1, 2, 3, 4, 5, 6, 7. I've moved it 7 places, and the coefficient out in front becomes 1.89, and then it's going to be times 10 to the 7th because we moved it 7 places, and because 18 or 19 million is a really big number, much bigger than 1, the value of that exponent is going to be positive. Okay, so let's try to quantify that. Or put that into words. That's not quantifying. That power of 4, that number in the power, tells us how many places we move the decimal. So that is how many places we moved the decimal, and that's looking just at the number to give us that. For the sign, write that note somewhere else, and then I'm going to grab a different color. There we go. The sign tells us the value of the number is less than 1. Right, it's because that's what a negative exponent means. A negative exponent means that the value of the number, the 0.000135, is less than 1. And then when we have a positive exponent, the number is going to be greater than 1. So here are some practice problems. I strongly recommend that at this point you pause the video, you try these 4 problems yourself, and then you resume the video to see if our answers match. All right, go ahead and hit that pause button now. All right, so to work these out, for problem number 1, we're going to move the, well, let's write this with 1 digit to the left of the decimal. I've got 6.7 times 10 to some power. Because the size of this number is smaller than 1, I'm going to go ahead and write in the negative sign. And I'm going to move the decimal 1, 2, 3. I'm going to move the decimal 3 times. So that's going to be 10 to the minus 3. For this next number, I'm going to have 9.8530. Oh, I forgot to mention this on the previous slide, so I'll write that in here. The original number in normal notation and our answer in scientific notation need to have the same number of significant figures. So for sig figs, look at the number before the power of 10. Or in front of. So look at the number in front of the power of 10. And we need the same number of significant digits in both. Yeah, when I say in both the normal notation and scientific notation. So I need the same number of sig figs in normal and scientific notation. All right, so with that second number, the leading zeros are never significant. Then we have the non-zeros, which are always significant, and then we've got a trailing 0. Since the decimal point is written, that trailing 0 is significant. So when we write this coefficient in scientific notation, we need to include that terminal 0 since it is a significant figure. And then because this is a number that's smaller than 1, our exponent will be negative. And then I'm going to move the decimal 1, 2, 3, 4, 5. I'm going to move that decimal point 5 times. So that becomes 9.8530 times 10 to the negative 5. For question number 3, we've got 23,000. And so if I move the decimal so that there's 1 non-zero to the left of the decimal point, we're going to get 2.3. These terminal zeros, trailing zeros, don't have a decimal showing, so they are not significant. So 2.3 is all that I need. And then it's going to be times 10 to some power. It's going to be a positive number because the number is bigger than 1. And we'll move it 1, 2, 3, 4. We're moving the decimal 4 times, so 2.3 times 10 to the 4th. Next up, we've got 6,670,000. Those trailing zeros are not significant because there's no decimal point. If I rewrite the number with 1 digit to the left of the decimal point, I'll have 6.67, and then it's going to be times 10 to a positive number because this is a number greater than 1. And then I'm going to move it, well, let's see, the commas in the number represent 3 places, so I'm going to move it. That's going to be 3, 6. That's going to be a grand total of 6 places. So 6.67 times 10 to the 6. When we're multiplying and dividing numbers in scientific notation, We need to be able to get at least a rough estimate of what our answer is without a calculator, because we often see students making mistakes running scientific notation through their calculator, and we want to make sure that when you get an answer from your calculator, you can look at it and say, whoa, that isn't even close because the power of 10 is way off. So we're going to go through how you would do multiplying and dividing without a calculator so that we can always double check the answer we're getting with a calculator. If you're going to multiply two numbers that have exponents where the numbers have the same base, we're going to add their exponents. So multiplying these numbers mean that we're going to add the exponents. Dividing means that we're going to subtract the exponents. So with this first number, we've got 10 to the 7th times 10 to the 41st. That is equal to 10 to the 7 plus 41, or 10 to the 48th. Now if we skip down to number 5, we're going to be dividing the exponents, or we're dividing these numbers, which means we subtract the exponents. So that's going to be 10 to the 23rd minus 6, or 10 to the 17th. At this point, I'd like for you to pause the video and work these out yourself and see if you can match what I get. So please go ahead and pause and work those out. All right, so on the second one, we're going to have 10 to the negative 5 plus 25, right? If we're going to add those exponents, that's going to work out to be 20. On the next one, we're going to have 10 to the 29th, if we just add those two exponents. And I am out of room, so for number 4, we're going to have 10 to the 20th, because 23 minus 3 is 0, or 23 minus 3 is 20. On number 6, when we're dividing those exponents, or dividing those numbers, we subtract exponents, so that's going to be 10 to the 23rd minus a negative 6. So 23 minus a negative 6, that's going to be equal to 10 to the 29th. And the next number is going to be 10 to the 5 minus 3, which is the same thing as 10 squared. And that last one is going to be 10 to the 5th minus a negative 3, which is the same thing as 10 to the 8th. Whoa, sorry, 10 to the 8th. All right, once again, I'd like for you to, I haven't shown how to do this whole thing. Sorry, I was going to ask you to pause it, but let me show you how to think about these. When we're doing multiplying and dividing, we can group the numbers in any way that we would like. And so what I'm going to do here is take the coefficients and group them. We're going to do 6 times 3, and I'm going to take the powers of 10 and group them. 10 to the 23rd times 10 to the 3rd. And so this is going to give me 18 times 10 to the 26th, but 18 is the same thing as 1.8 times 10 to the 1st, and then that's still times 10 to the 26th, and so that's going to work out to be 1.8 times 10 to the 27th. We can't leave our number is 18 times 10 to the 26th, because that's not scientific notation. Scientific notation has only one digit to the left of the decimal, so we had to rewrite that. For this next one, we're going to have 6 times 10 to the 23rd divided by 3 times 10 to the 3rd. I'm going to group this by doing the normal numbers and then doing the powers of 10. So 6 divided by 3 is 2. And then that'll be times 10 to the 23 minus 3, or 10 to the 20. All right, take a moment here and work these two problems out. All right. Hopefully you got the same results as I did.